All right, so today we're just going to add in how you can identify if an equation, set of equations has no solution or infinitely many without graphing it and without having to find the slope and the y-intercept. So if you want to leave them in standard form, you can actually use what we did yesterday, which was elimination, and identify whether or not it has a solution. So solving a system of algebraic equations does not always provide a unique solution. So all the homework questions we had an independent system, or we got an answer. We can also get infinitely many solutions, which we classify as a dependent system. Or we can get no solution, which we also call an inconsistent system. Now, when they ask you what is the solution or solve, your answer would be one of these two things instead of the inconsistent or independent. If you want to write both, just to be safe, you can. So on Monday, we learned how to figure out the number of solutions by getting it in slope-intercept form, observing the slopes if they were the same or different, looking at the y-intercepts. You can do that here as well, but you also can use elimination to determine it as well. So looking at, we could eliminate either the x's or the y's because they both have matching coefficients, 3 and -3. They have opposite signs. So I would just add downward. I don't even have to multiply. -3x plus 3x is 0x. Normally I don't write that, but I'm going to in this note session. 1 plus a -1 is 0y. And -5 plus 5 is 0. So no matter what I plug in for x or for y, I'm multiplying it by 0, and 0 plus 0 will get 0 equals 0. So is that true? Yeah. 0 is equal to 0. So this is going to be one that has infinitely many solutions. We also call that a dependent system, but they asked us how many solutions. So this is the answer. Some students also like to write dependent because they're not sure when they're supposed to write that. You're only supposed to write that if they say classify it as independent, inconsistent, or dependent. If they ask you for the solution or finding the solution, we would say infinitely many. So the next one, same thing. Notice this time I could eliminate this variable if I were looking at it. And I have different signs, which means I'll add. 4 plus a -4 is 0x. -6 plus 6 is also 0y. But 6 plus 10 is 16. So I'm going to get 0 plus 0. Does 0 equal 16? No. So whenever you get that the variables have disappeared, both of them, you're just left with numbers and they're not equal, that's when we'll say that this solution is a no solution. Excuse me. The system has no solution, which we also have called an inconsistent system. Okay, so basically what we did yesterday, just observing sometimes the variables both will cancel out or eliminate themselves, and we'll get a special type. See if you guys can try the next two real quick. Alright, so for example 5a, I showed that I multiplied the top one by 2 to get matching coefficients. When you guys solved this out, did you get a no solution or an infinitely many solutions? Garrett?
No solution.
No solution. Let's double check. We have 0x plus 0y equals -4. We'll get 0 is equal to -4, which is not true. So that is a no solution. Perfect. And how about an example B? Jade? Good. Infinitely many. I multiplied the top equation. I did a -3. Again, I suggest having different signs. That way you're adding and you don't have to make the mistake of subtracting. You can just multiply by 3 and then this would be a minus, but you'd have to make sure you went out to the minus side and back to the number. So for this one we should get 0x plus 0y equals 0. 0 is equal to 0, so that's our infinitely many solutions. And again, that would be a graph of a line that falls directly on top of the other line. That's why it has infinitely many solutions. Every single point on the line is a solution. Okay. All right, I'm going to go ahead, and I think you guys are doing good with this stuff. So I'm going to let the back be a little partner challenge for you guys to work on with a partner. So there's 2 multiple choice questions. You will need to show some work. And then there's a closure, that's a word problem. I'd like you guys to try that as well. So go ahead and work on these with a partner, and then when you guys are done, come on up, bring your papers and show me your answers. And then I'll give you your homework as soon as you guys have completed those. So for number 3, it said Samantha and Maria purchased flowers. Samantha purchased 5 roses for X dollars. You can see that's represented here. And 4 daisies for Y dollars. And spent $32 in total. Maria purchased 1 rose for X dollars and 6 daisies for Y dollars each and spent $22. So first of all, they're telling us that X equals the cost of 1 rose. Roses for X dollars, and Y will equal the cost of 1 daisy. So we are going to solve this system. To solve the system, I would probably look at my coefficients, and I'm thinking I'm going to make this one into a -5. So to do so, I'm going to have to multiply the whole equation by a -5. The first one, I'm going to leave exactly as it is. Make sure you do multiply it all the way over. And then because I have different signs, I'm going to add them. 5 plus -5 is 0. 4 plus -30 is -26y. And 32 plus a -1 time, we would subtract those and get -78. And lastly, we would divide to get y equals 3. Number 3 is the cost of 1 daisy. So 1 daisy costs $3. Now to find out the cost of the rose, we need to plug this back into one of the 2 equations. So we would have 5x plus 4 times 3 equals 32. She'll get 4. So 1 rose costs $4. Now let's read the answer choices. A rose costs 1 more than a daisy. A rose costs 1 more. That's true, but let's read all the other ones. Samantha spent $4 on each daisy. No, she spent $3. So that's wrong. Samantha spent more on daisies than she did on roses. Samantha, well, 5 times 4 is 20, and 4 times 3 is 12. So no, she spent more on roses, so that's wrong. And Maria spent 6 times as much on daisies as she did on roses. Well, Maria bought 1 rose, so that's $4. And she bought 6 daisies. 6 times 3 is 18. That's not right either. So the correct answer was A. Always make sure you eliminate the other choices as well. And then this one says Juan answered all 50 questions on a test. He earned 3 points for each question he answered correctly. He lost 1 point for each question he answered incorrectly. His final test score was 102 points. And the system of equations below describes the relationship. So all of this junk up here was just given to write the equations, which they did for us. Now, we do want to pay attention to how they define the variables. The number of questions he answered correctly is our x variable. The number of questions that he answered incorrectly is the y variable. So if we read through the problem, it says part of the solution of the system is x equals 38. So if you were to solve this, you would actually get a solution of x equals 38. What does this value represent? So we actually don't have to solve it. They solved it for us. We just need to go back up and see how did they define x. X is the number of questions he answered correctly. So this means that he answered 38 questions are correct. So that would be the number of questions Juan answered correctly. That's it. Let's double check. The number of questions he answered incorrectly. No, that would be what his y coordinate would be. The number of points Juan lost from the questions. Nope. The number of points he earned. No. Because each correct question was worth 3 points. So you'd actually take 3 times 38 to get that. So the answer again was A. The last one is an open-ended question, and it says a student has some $1 bills and some $5 bills in his wallet. So let's let X equal the number of $1 bills and Y equal the number of $5 bills. He has a total of 15 bills that are worth $47. How many of each type does he have? So first of all, if he has 15 total bills, that means we're going to take the number of dollar bills plus the number of $5 bills and equal 15 bills. So one of my equations is X plus Y equals 15. Remember, the equation that uses the 47 has to have dollars in it. So $1 times X plus $5 times Y has to equal $47. And then from there, we actually can go ahead and solve this. I'm going to go ahead and multiply this by a -1. And I'm going to leave the other one exactly as it is. That way I have different signs. When we have different signs, that means we can add them. So we have 1 minus 5 is -4. 15 minus 47 gets me a -32. And then whenever I divide those, I will get that Y equals 8. Plugging the 8, I would choose to plug it back in here. 15 minus 8 will give me that X is 7. So that means that we have 7 $1 bills. And we have 8 $5 bills. Okay, the homework is the 3.1 to 3.2 practice worksheet, and you should check your answers to that online.